Welcome to today's deep dive. If you use AI tools daily, you already know they don't start out acting like helpful assistants.
Nice. They definitely do not.
Our mission today is exploring a fascinating Stanford University lecture on LLM tuning to discover exactly how AI models go from being raw text predictors to acting like friendly, safe companions.
Because that transformation is, well, it's a massive shift in how the system behaves.
Okay, let's unpack this. Because the core problem highlighted in the lecture is that after its initial training, an AI is essentially just predicting the next word. It knows facts, but it fundamentally lacks tact.
Yeah, at that pre-training stage, it's just generating text based on statistical probabilities. There's no concept of human empathy.
Right.
And the lecture illustrates this perfectly with the teddy bear problem, comparing supervised fine-tuning, or SFT, with preference tuning.
Because if you ask an SFT model whether you can put a teddy bear in the washing machine, it just bluntly says, no, it might get damaged.
Exactly. It's cold. It's a factually accurate rejection, but it's cold. Preference tuning shifts that tone to be gentle.
Gentle and empathetic, yeah.
Right. It outputs something like, it's better not to, your teddy bear could get hurt.
Yeah.
It's the exact same factual payload, just calibrated for a better user experience.
But getting that calibration right introduces a massive layer of complexity, right?
Oh, absolutely. The lecture points to RLHF, reinforcement learning from human feedback. First, you have human annotators rank pairs of AI answers.
To see which one is actually better.
Exactly. And that trains a reward model, which basically acts as an automated judge. Then the AI uses an algorithm called PPO to maximize its score from that judge.
What's fascinating here is, the danger there is reward hacking, right?
Yeah, what's fascinating here is exactly that vulnerability to reward hacking. The lecturer compared it to a professor whose only metric for success is the volume of applause at the end of a class.
So if they realize students cheer louder for stand-up comedy than calculus.
They'll just tell jokes. The metric is maximized, but the actual objective of teaching is completely lost.
An AI will do the exact same thing.
Right. If it blindly chases a high score, it might just output overly agreeable nonsense. So the AI has to be mathematically constrained so it doesn't lose its base knowledge just to chase a high reward.
Here's where it gets really interesting. Because managing that constraint alongside a separate reward model is a technical nightmare.
It's a huge headache for engineers, which is why they look for shortcuts.
Like best of N. Instead of complex reinforcement learning, you just have the model generate, say, 5 different answers to a prompt.
The reward model scores all 5, and the system just outputs the best one to you.
But the fatal flaw there is the computing power, right? That inference time.
Yeah, inference cost is the killer. Generating 5 responses means doing 5 times the computational work every single time you submit a prompt. It's too slow and way too expensive for everyday use.
So the industry needed something simpler than RLHF, but faster than best of N, and that brings us to DPO.
Direct preference optimization. It's a massive shift because it skips the reward model entirely.
It just directly tunes the AI's weights, right?
Exactly. It directly tunes the internal weights based on those human preference pairs. No separate judge, no complex PPO algorithm. It's much simpler to train.
Even if traditional reinforcement learning sometimes edges it out in raw performance.
Right. But the technical friction it removes makes it incredibly popular.
So for you, listening to this deep dive, this exact preference tuning, the invisible math of DPO and RLHF, is why the AI tools you use daily feel conversational and safe, rather than reading like a robotic encyclopedia.
If we connect this to the bigger picture, it changes how we view these tools entirely. We aren't querying raw data matrices. We're interacting with carefully sculpted personas designed to mirror our communication standards.
And that leaves you with a really provocative thought to ponder on your own. If an AI's entire personality and tone are shaped mathematically by human-ranked preference pairs?
Whose specific preferences?
Exactly. Whose specific preferences and cultural biases are we actually hardwiring into the AI brains of the future?